As I told you, I asked you to go through the trigonometry formulas in your mathematics book. Okay, so we'll be using that directly. The first one, so I'm going to go through this table which is given in your handbook. So first one which we talk about is progressive wave. So suppose if I take a rope like this, and if I give a pulse, what you will see is the pulse will travel forward. So that's something like a traveling pulse. But if I keep on oscillating it, okay, I told you to go through the PhD simulation. If I keep on oscillating it, right, you will see that the wave is kind of progressing forward. So it means energy from here is getting transferred to this end. And that is what we mean by progressive wave. So linear combination of sine and cosine waves. Okay, so suppose if I take y is equal to a sine kx minus omega t plus phi. What this means is I'm going to treat this as one single variable or one single bracket. And then this will be something like so sine A plus B, right? So sine A plus B is sine A cos B. That means I'll be getting cos phi sine A sine kx minus omega t. Plus I can say A is multiplied inside. So sine A cos B plus cos A sine B. So sine B cos A. So phi is the initial phase. So what do you mean by initial phase? Suppose if you have two different waves. Okay. So this is one wave. Let's say this is another wave. So the angle difference between this peak and this peak, that's what we would call it as phi. So what this means is, suppose if you have two waves like this in this format, okay, then you can represent it as one single sine wave here. So this is one wave and this is another wave. So both are having a phase difference of phi. Resultant amplitude and phase difference. Okay. How do I do this? A squared plus b squared. So I'm taking this as A, taking this as B. So A is the amplitude of the first wave, B is the amplitude of the second wave. So this is one wave and this is another wave. Okay. So based on this formula, I can write this as A sine kx minus omega t plus phi. So that means this is your resultant wave. In a way, I'm just going in the, instead of going this way, I'm just trying to explain it this way. To take it down, this is the amplitude of the first wave. This is the amplitude of the second wave. Suppose if I want to find A, or suppose if I want to find phi, I have to eliminate A by dividing equation 1 by equation 2, something like that. If I want to eliminate phi, I can do square it and add it. So if I square it and add it, I'll be getting why would I do that? Because it will become A squared is equal to A squared cos squared phi. B squared is equal to A squared sine squared phi. If I add this and this, I'll be getting A squared plus B squared is equal to A squared. If I take it commonly out, I'll be getting sine squared phi plus cos squared phi. This will become 1. So what is left is A squared plus B squared. So if you're wondering what is the use of doing this, if I want A, I can do square root of A squared plus B squared. What does that mean? A is the amplitude of the resultant wave. So take it down. A is the amplitude of resultant wave. In my opinion, the mathematics is very, very simple, but you may have trouble, understanding what is what. Okay. So again, let me repeat it one more time. What I'm trying to say here is, this is wave 1. This is represented, this representation is wave 1. This representation is wave 2. Okay. So if I have something in terms of sine and cos in 2 different waves, right? I can write it like this, which means I can, add this to this form, which means whatever is in front of sine is your amplitude. Whatever is in front of cos is also your amplitude. So this is the amplitude of first wave and this is the amplitude of the second wave. So after that, this is your resultant wave. So if 2 waves are going in the same row or same particle, set of particles, then you can get the resultant wave, something like this. Anybody not following, please ask me. After that, these mathematics is the easiest part. Okay, understanding what this means. So if I want to, if you give me the values for A and B, and if you ask me what will be the resultant amplitude, then I can simply use this formula. Suppose if I do B by A cancels, so I'll be getting sine phi by tan phi, sorry, cos phi. This is nothing but tan phi. So here I eliminated the phi. Here I'm eliminating the A by doing division. That means phi can be found to be tan inverse of B by A. So any equation given in this particular form, I can tell what is the phase difference for the resultant wave with respect to the first wave or these 2 waves. So based on this, suppose if you give me the A value and B value, I can tell what is the phase difference for the resultant wave with respect to the input waves. So these 2 are the input waves and this is the resultant wave. I don't following anything not making sense, please ask me. So take down the steps. In the handbook, I have not shown you all the steps. Okay, if I go here, so look at this. I given you only the final answers. So unless you do these steps, you'll not be able to get the answer. Okay, the next topic is this is for a progressive wave. So two different waves, coming together. This is something like, linear combination of sine and cosine. Okay, because this is one wave is in sine and another wave is written in terms of cosine. The next one is superposition. Interference. Equal to A sine kx minus omega t. Suppose if I say this is one wave, and if I say there is another wave, this is very, very important for your 12th also. Okay. Only thing you'll be studying about light there. So light waves you'll be studying. The concepts, the formulas, everything is exactly the same. So study it properly. So sine kx minus omega t plus 5. Sir, I have no idea what you're saying. Well, it's very simple. What I'm trying to say here is this is wave 1 and this is wave 2. So wave 1 and wave 2 is having a phase difference of, let's say this is one wave and let's say this is another wave. Okay. So if I tell you the phase difference between this wave and this wave happens to be 5, then this is your y1 and this is your y2. Okay. So I can write it like this. And if I want to find what will happen if I superpose them together. Okay, what it means is, suppose if you take a bucket of water and if you drop a small stone over here, you will see the ripples are kind of going like this. Suppose at the same time, suppose if I drop one more stone over here, this will also produce some waves here. So this wave will also progress and this wave will also progress. Both are kind of superposed on the same place. So the particle which is somewhere here, it will be experiencing the movement because of this wave and it will be experiencing the movement, up and down movement because of this wave. So sometimes it will do constructive and sometimes it will do destructive interference. Okay. Again, I don't want to confuse you right now. These things are coming in your 12th standard. So what I'm trying to say here is, suppose if you have a wave like this and if you have a wave like this, listen carefully. The phase difference between this wave and this wave is phi is equal to 0. Okay, this we call it as in phase. So both the waves, we say it is in phase. But suppose if you have one wave like this, if you have another wave like this, you see this peak and this peak, the phase difference will be 180 degree.
Actually, they have a phase difference of pi by 2, sir.
This one or this one?
The second one, sir, the phase difference is pi by 2.
Pi by 2.
Sorry, sir, pi.
Pi, yeah. It will be 180 degree, okay, or pi. Or I can draw it a little better. Okay, if you draw it in a scale properly, it will make more sense. So this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi. So that means this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees. But then very often we talk in terms of pi. So that means it will be pi by 2, pi, 3 pi by 2, 2 pi. This will be 0 degrees and this will be 0 pi. So the first wave, if I were to draw it like this, the second wave, I would draw it suppose, if it is something like this, something like yours, displacement and acceleration in the previous chapter. You see, when this is going upwards, this is going downwards. When this is going down, this is going up. Okay. This kind of wave, we call it as 180-degree phase difference. Why? Because look at this. I'm supposed to find the angle difference between this and this. So from this peak to this peak. So what is the difference? 270 minus 90, which is 180 degree. Or you can also write as pi. Why? 3 pi by 2 minus pi by 2 will give me pi. 2 pi by 2. So 2 cancels, so I'll be getting pi. Everyone following this? Take it down properly. Okay, if you don't understand this, so that's what I tried to show you in this wave. When this is going up, this is going down. So Chaitanya, to make it clear for you, right? It's good that you got confused here. So if it was 90 degree, the peak should be appearing somewhere here. Suppose if you had a curve like this. This, I would say, look at this peak and this peak. This peak is appearing around 180. This peak is appearing around 90 degree. This way. So 180 minus 90, it will give me 90. Is that okay, everyone? Chaitanya?
Yes, sir.
Okay, again, I don't want to confuse you. Too many curves in the same graph. Okay, so take it down, one thing properly. So now that you know what is phase difference, right? So it can be 0, it can be 180 degree, it can be 30 degree, it can be 60 degree, it can be anything. So this is what we mean by the phase difference between the two waves. So take it down. Phase difference between the two waves. Phase difference between the two waves, or you can say phase difference of wave 2 with respect to wave 1. So take it down properly. Very important, very confusing. Definitely these chapters, as I've been telling you, it's not an easy one. It takes a lot of effort. So all I can say is I can just, try to teach as much as possible. So some of you might be getting 80%, some of you may be getting some 60%. Okay, I mean your understanding level, I mean. Okay, at least even if it is above 50-60%, then it means you are doing well. As you keep studying this again and again, okay, it will make sense. Okay, again in 12th standard also you'll be getting the same things. This is one of the reasons why they teach you this, okay, skipping the thermodynamics sometimes. Okay, anybody remember the formulas? Sine A plus sine B. take this as, say, C. Take this as, I'm going to try this formula C and D. So somewhere you must have studied sine C plus sine D is equal to anybody? 2 times. Nobody remembers the formula.
And sin x plus sin y is equal to 2 cos x plus y divided by 2 plus sin, sorry, 2 sin x plus y divided by 2 cos x minus y divided by 2.
Very good. So instead of x and y, I have taken C and D. Okay, so it's the same thing what you said. That means 2 times sine C plus D by 2, sine C minus D by 2. So this is a formula which you are going to apply here. Double check in your trigonometry mathematics. You're okay with this? Do you agree? I hope this is the correct one. That's what Chaitanya also told me. Is that okay, Uzma? Is this correct or not? No answers from Uzma. Okay. Anybody else? Ashwant, have you studied trigonometry formula? This one?
Sir,
Have you studied this formula or not?
no, sir.
No?
No, sir.
Okay. I'm sure it's there in your textbook. Go back and study. Okay. So suppose if I apply this formula here, right, what will happen is I will get this term plus this term. Okay, let me write it in yellow. Y1 plus Y2. I'll be getting 2 times A. What did we say? Sine C plus D. So what is C plus D? Kx minus omega t plus Kx minus omega t plus phi divided by 2. Cos, what did we say? C minus D by 2. Kx minus omega t minus Kx minus omega t plus phi. Of course, I'm just showing a lot of steps here. Okay, so you know that this and this will add up. This will be pi by 2. So I'll be getting 2 times Kx minus omega t. Just to avoid any confusion, I'm just showing a lot of steps. In reality, in your exam, you don't have to show so many steps. You see, this is Kx minus omega t, and this is minus Kx minus omega t. So both will cancel. This will become minus pi. This will become 2 and 2 will cancel, and this will be pi by 2. So sine anybody, what is cos minus theta? Trigonometry formula. This is positive theta. Looks like nobody has studied trigonometry. This is minus theta. Okay. So what can you say about the cos in the fourth quadrant? All silver, teacups. So cosine is positive here. So that means cos minus theta can be written as cos theta. Okay, so that's a mathematical formula you should know, which means this can be written as pi by 2.
Cos phi by 2.
Yeah. Generally, we like to write this constant terms in the front, so I have to write pi by 2 in the front. Any doubts so far? So this is what I've shown you in the handbook. Okay. So what this means is this is your amplitude. So whatever is in front of sine, I told you that is your amplitude. So this is the amplitude of the resultant wave. Can anyone tell me what is the phase difference of the resultant wave? What is the phase difference of the resultant wave? Kirtan, can you say? Kevin? No answers. Padmaja?
So this is it 5 by 2?
Yeah. So whatever is this additional term, that will be your phase difference. Phase difference of resultant wave. So take it down. So this is the first wave. There was no phi. So if you see the first wave, that means with respect to the first wave, the phase difference is pi by 2. With respect to the first wave, the phase difference of the second wave is phi. Phi or phi, whatever you want to call it. Phase difference of resultant wave with respect to wave 1. What is y? Anybody? Atish? Atish, I'm talking to you. What is y? Okay, I think I have to remove some of the students who are not responding. Let's see who are the ones who are responding. Kirtan, are you there? Why there is
Yes,
no
sir.
response? I asked you a question earlier. Why you didn't respond?
I didn't want to get to know the answer.
Atish, are you there or should I remove you? Okay, Chaitanya, you are there. Hafiza, are you there? Hafiza, talking to you. If you don't respond, I'll remove you. Okay, Mithun, are you there?
Yes, sir.
Ashwant, you stopped. Okay, Padmaja. Roshini, are you there?
Yes, sir, I'm there.
Okay, Siddharth,
Yes, sir.
Uzma, no response from
Yes,
you
sir.
earlier. Veer,
Yes,
are
sir,
you
I'm
there?
there.
Yes. Yes, sir. Yes, sir.
Okay. Hafiza, why you are not responding if I ask you a question?
Sir, yes, some network issues, sir. That's why I can't able to respond properly, sir.
And now how it's working now?
That's what I turn on my modem sound. Only it's not coming properly. Sir.
I wish this online class ends very quickly. It's very, very irritating. So next year I'm not going to conduct any online classes. So if you want, drive 1 hour or 2 hours, I don't care. Okay. So the folks are not worth it. So suppose, in the examples which I gave you, if the phase difference is equal to 0, what will happen? So let's talk about the special cases. So when phi is 0, cos 0 will become 1. So I'll be getting 2 times A. So when it is in phase, what will happen? The amplitude will increase. So the amplitude will increase. So it will become double. So that's why, when this is 0, cos 0 is 1. So it will become 2A.
So, even if phi is equal to 180 degrees, it will be the same. It will be 2a sine kx minus omega t.
Yes, sir.
Say that again. So 180 by 2, what will happen?
Cos 90.
Cos 90 is what? 90 is what? Cos 90 is
0.
0. Which means if you have one wave like this and if you have another wave like this, what does that mean? This particle is trying to go up and this wave is trying to push it downwards. This wave is trying to push it upwards. So when you add this, what will happen is it will be like, almost 0 like this. So the amplitude here is 0. So that's what, you are seeing from this. Any questions so far? So this is what is given in your handbook as in a tabular format. Okay. So 2a. So in phase means it will become 2a sine kx because phi becomes 0 here. So the phase difference between the resultant wave and the first wave is 0 because phi becomes 0 here. When it is 90 degree, sorry, 180 degree, then the displacement will become 0. Okay. So that's what the special cases are given here. So if any of you are wondering, sir, the first one also looks something very similar. Well, if you are thinking like that, you are 100% right. So both are almost the same. Only thing here, these are two different waves, which are given in terms of sine with the phase difference phi. Here, the two waves are given in terms of cos and sine. So one wave is given in terms of sine, the another wave is given in terms of cos. So in that case, you have to use this formulas. If both are given in terms of sine with a phase difference phi, then you'll be using this one. This was with same amplitude. Okay. What if you had a different amplitude? Okay. So this is coming in your 12th standard. So I'm not going to teach it right now. Okay. So that's why I put a plus. So if I put a plus, it means it's not there in the textbook. Okay. But it will be required for your entrance exams. Because we don't have time to complete the even basic ones. So first let's focus on the basic ones, okay, and then come to the difficult ones. Wave optics, again, this is coming in your 12th standard. Okay, so we'll come back to it. The reason why it is given here is when you study this chapter and the 12th standard chapter, it will make more sense. So you have to study them together. We have a very interesting experiment to show in this particular thing called standing waves. Okay. For a minute, I'm going to stop sharing. I will show you a video here. So give me a sec. Because the standing waves, I can talk for 10 days or 20 days. It's not going to make any sense to you. Okay. But if I show you a 5 minutes video, it will make a lot of sense. So that's why I want to show you a video. And myself, I want to keep quiet. We have some experimental demonstrations. So I'll show you the links. So if you type standing waves in YouTube, you'll be getting this. Okay. So very, very interesting demonstration. Okay. So this person, this professor probably, he's doing a very good job here. You may not be hearing the audio, okay, but so this is a frequency generator, right? And he is connecting it to a oscillator here. So this is connected to a string here, and this end is fixed. So as you vibrate this, something like a guitar string, right? What will happen is this will be forming some loops. So you see right now he has set it up at low frequency. Now he is increasing the frequency. So that's what is called a frequency generator. So as I keep changing the frequency, I can keep oscillating at a higher frequency. So what's happening here is one wave is going forward, and then it is reflected back at this end, and it is coming back, right? One wave is going forward, and then another wave is coming back. In this kind of situation, you will be forming these kind of loops. So right now you are having two loops. I will teach you the theory, but first of all, look at the video properly. So what he is explaining here is, this is like a nodal point. This is like an antinode point. So in the nodal point, what happens is the forward wave and the reverse wave both are cancelling out. When they cancel out, the amplitude here will become 0. You see, that's a slow motion. So that is one wave going, and then another wave is coming back. Okay. But in reality, you will be seeing only something like this. So this is called the nodal point. In nodal point, the displacement is 0. Why? Because there is no vibration at all.
No vibration.
Yeah, you are right. Here, the vibration is maximum. Okay. So this point is called antinodal point. Okay, antinodes.
It's just a substituent word for amplitude in this case.
It's a substitute for what?
Amplitude, the word amplitude. Like the
amplitude.
crest and trough, crest for the top.
Yeah, you are right,
normal,
but you are right, but then nodal point and antinodal points happens only in standing waves. Okay. Right now we are talking about standing waves. So you see, this is what you will see in a slow motion. But when you see it in reality, right, it looks like, the thread is everywhere, right? You know that based on your logic, you can think that the thread is going to be in only one place at a given instant. But since it is moving so fast, you think that, it looks like a loop. Now he is increasing the frequency. Now I think he is increasing the frequency further. So you see now instead of two loops, first he showed one loop, then he is showing 2 loops, and then now he is showing 3 loops. So you see, this is a nodal point, this is also a nodal point, this is antinode, antinode, antinode. Okay, along with the audio, you can watch it later. Okay, very, very useful. Okay. So Kirtan, what you are saying is it is very similar to earlier, but then in a progressive way, what happens is this point will also move up and down
Yes,
at a different instant. But here you see there is no movement at all. Okay,
okay.
and that's why it's called nodal point. And this point is moving maximum, so that's why it's called antinodal point.
Okay, sir.
So let's see what he's doing next. Yeah, what do you think he did? He's increasing the frequency further, and you can see more and more loops. This you can actually do it. Okay, if you have a small thread or a loop, rope, take the rope and then ask somebody to hold it on one end, and then it should be like half your room size, or entire room size. You go and stand on the other end and you start vibrating, and you will see this kind of loops. Okay, so try this experiment. If you get a good result, try to do a video recording and send it to me. You can share it with others also. Okay, so I'm going to come back. So let me try to explain the theory here. Okay, I hope you are getting some idea. Okay, so what's happening here is, if I take a rope and if I send a wave here, the wave is going to go like this. This is what is called progressive wave. So take it down. This is what we talked about earlier so far. But now we are talking about something different. So you take the rope and you hold it stationary at one point. So when the wave is kind of going here, listen carefully. As soon as it hits this stationary point, what will happen is, if I throw a ball, what will happen? It will come back in the opposite direction here, right? So similarly, the wave also does something very similar. Okay, very hard to imagine, but that's what the wave is also doing. So the wave will be reflected back like this. That's why I said, I can talk for 1 month and it's not going to make any sense to you unless you see a demonstration or a video. So this is what you are actually seeing, okay, as a loops. So this, the solid line, I would call it as incident wave. The dotted wave, the dotted line, I would call it as reflected wave. So what's happening? The same rope, right? Earlier we had only progressive wave. Now you have both progressive wave is also going this way, and then the reflected wave is also coming in the same rope. And this is why you see the loops. In the earlier case, you would not see any loops. You will just see the rope going up and down. Whereas in this case, suppose if you keep one point stationary, then you will see the loops. Okay, and this is what we call it as standing waves or stationary waves. So take it down. Standing waves or stationary waves. Why? Because it's the opposite of progressive. So here the energy is moving forward. Here the energy is moving forward, but then it's again coming back. So take it down, very important. Here energy is moving forward. I told you very important sentence at the very beginning of waves. Wave is nothing but energy transfer mechanism. So the energy from this point A is transferred to B, and that is what we mean by wave. The energy from sun is reaching us even though it is millions of kilometers away. So that's what is called energy moving forward. However, here what's happening is here energy is moving forward, but then after reflection it is coming back. Okay, so since the energy is coming back, right, we say that there is no energy transfer. Even though within this small region the energy is going and then coming back, it's not moving forward. Okay, so we say, take it down, very important. In stationary waves, energy is not transferred. I don't have space at the bottom. Okay, so maybe I can try to make it bigger. Energy is not carried forward. Energy is not carried forward as in the case of progressive wave. Any question? Are you getting the idea of what is a standing wave? So very often you're going to hear the word standing waves or stationary waves. Okay, in your 12th standard also. Okay, so study it properly. Okay, so with that introduction, right? So you know what is standing wave. With that introduction, I need to talk about one more concept here. When you put minus omega t, right, it represents the wave moving forward. When you put plus omega t, right, it represents the wave which is moving backwards. This is a bit confusing unless you see this mathematics here. Okay, so look at this. Again, this is not required for exam purpose, but only if you are convinced with this idea, you will understand why it is minus omega t in one place and plus omega t in another place. So look at this. This is sine theta. Okay. So sine 90 will become 1 here. Sine 270 will become minus 1, right? So this point. But suppose if I do theta minus pi by 4, what does that mean? Suppose if you take 90 minus 45, pi by 4 is nothing but 45 degrees. So 90 minus 45 in the second case, in this particular location. If I do 90 minus 45, I'll be getting 45. So sine 45 is somewhere around 1 by root 2. So So which is around this value 0.7. And suppose if I go to say 135 degrees, 135 minus 45 will give me 90. So sine 90 will give me 1. So you see, when I do a minus here, it looks like the wave is moving forward. So compared to the red one, the blue one will be somewhere here. And compared to the blue one, the black one will be somewhere here. So what this means is when I do minus of something, right, this wave will be moving forward. So that is why I'm going to say that kx sine kx minus omega t, I'm going to call it as incident wave, which means the wave is progressing this way. YR, I'm going to call it as reflected wave. So A sine kx plus omega t. So this is the reflected wave. So that means it's going to come back like this. Suppose if you do the same math, if I put plus pi by 4, the wave will be appearing somewhere here, yellow line, which means it's moving towards your left. Here, this is moving, when you put a minus, it's moving towards your right. This is a bit confusing. Only if you bring in the mathematics and if you try this out, this will make sense. Okay, so for now, you have to try this and then you will get convinced. Everyone following this incident and reflected wave? Chaitanya?
Yes, sir.
Following it? So that means the same rope, right? Listen carefully. In the same rope, you are going to get both incident wave and reflected wave. So the rope which the YouTube, this was vibrating here and this was stationary. So this wave is going like this, and then this wave is reflected back like this. Okay, that's why you see the loops. So the resultant, Y resultant, displacement, right? Y is nothing but your displacement. Self-explanatory. I don't have to explain anything, right? YI and YR. So A, I'm going to take it out commonly. So I'm going to get sine C plus sine D. What did we say? Sine C plus sine D. Earlier we used the formula. 2 times sine C plus D by 2
X.
cos C minus D by 2.
Sir, 2a sine kx cos omega t.
Okay, very good. Omega t will cancel. So I'll be getting 2 times kx divided by 2. So 2 and 2 will cancel. So I'll be getting sine kx. Okay, so if you want, I can write one extra step to avoid any confusion. If I do this minus this, what will happen? Kx and kx will cancel. Minus omega t, I'll be getting minus 2 times omega t divided by 2. So 2a sine kx. Just now we studied cos minus theta will be cos theta, which means minus will go away. 2 cancel, so I'll be getting cos omega. So this is starting from a node. Suppose if the wave was looking something like this. So what is the y displacement at a given location? And this is what this equation is telling you. So for a given location x, right, with respect to time, listen carefully, very, very confusing because it is kind of continuously changing, right? So it's not a very easy thing to imagine what I'm trying to say. So please listen carefully. When time t is equal to 0, let's say the wave was something like this. When time t is equal to 1 second, let's say the wave was like this. When time t is equal to 2 seconds, let's say the wave was like this. So that means, listen carefully, if I take a particular location here, particular x here, the amplitude for the displacement keeps changing, but the amplitude for a given location is not going to change. Why? Because for this particular location, this is the maximum. Okay, I'm running out of battery. Let me connect my power cord just a second. So what I'm trying to say here is at different time instance, the rope is kind of moving up and down. But the maximum amplitude, right? If you see the maximum amplitude for a given location x, so suppose if I take this as the x location, this is the maximum amplitude you are going to get. So it can be here at t is equal to 1 second, t is equal to 2 seconds, t is equal to 3 seconds, but the maximum amplitude is fixed. Okay. If you take some other location here, this is the maximum amplitude. It cannot go beyond this. Okay. So that is what we are going to say here. This is what is your amplitude. Okay. As time changes, the displacement will change. But the amplitude is going to be same for a given location. So take it down. Bit confusing. So if anyone is not following, please open your mouth and tell me. I can try to explain one more time. Okay. All these things would be very easy if I'm explaining it face to face. Okay, because we have a spring demonstration here. So take it down. For a given location, of x, the maximum displacement. What do you mean by displacement? Maximum displacement, amplitude. The maximum displacement amplitude is a constant, is fixed or constant. given by 2a sine kx. Why? Because that is what I see in front of cos omega t. Anybody not following? Please raise your doubt. Any questions? Can I move on? So this is what I have. So this is what I have shown here in standing waves. Okay, a sine kx minus omega t, a sine kx plus omega t. So you get this one. Starting from a node for a given location x, the amplitude is constant, which is 2a sine kx. This is a little bit advanced concept. So if you start from here, suppose if your starting point was here, then there will be a lambda by 4. So this part, this entire thing is lambda. Okay, this is a bit confusing. So let's try to explain this in the drawing. You see, this is one full lambda. Suppose if the standing waves are formed, instead of forming like this, suppose if it was formed like this from this location. Of course, this will continue further. I'm just showing you part of it, right? But I want you to see only within these lines. So suppose if this was your starting point, suppose if the waves were starting, okay, in that case, I should not draw this side. So suppose if it was starting from here, then the location of this x, okay, there I need to subtract this lambda by 4. Okay, what it means is it's a phase difference. So what is the phase difference between this wave and this wave, right? So the peak over here is this one. And in the actual wave, I'm starting from here. So this is entire thing is lambda. This is lambda by 2. So this distance will be lambda by 4. Okay. So for that reason, we put y is equal to 2a sine kx cos omega t. This can be rewritten for this location, right? So when this is 0, when x is equal to 0, the amplitude or the displacement is 0. So when I put 0 here, the amplitude will become 0. Yeah, the displacement will become 0. But here, listen carefully. When I put x is equal to 0 here, right, I already have an amplitude here. So I'm supposed to get the maximum amplitude at this point. When will this be maximum? Only when it is pi by 2 here. So this will be written as 2a sine k. X is the location. So the location distance between this and this is lambda by 4. So x minus lambda by 4. So if you're wondering, sir, how do I know that it is lambda by 4? That's what I'm trying to explain here. So this is lambda and this is lambda by 4. Okay. So compared to this location, this is compared to this point is lambda by 4 ahead. So since it is ahead, I have to do a minus. This is what I told you, when it is coming forward, you have to put a minus here. When it is going backwards, you have to put a plus. Only when you do that, you will get this equation correctly. So if you want, you can try this, you can plot this graphs and see, and you will see that, when you plot this one, you will get a curve like this. When you plot this one, you will get that curve starting from here. I'm not sure if this is given in your textbook, but I think it might be given sometimes. Yeah. Any questions? So this is your standing waves or stationary waves. Okay. Somewhere did I show you something called onlinetonegenerator.com? Did I show you that experiment?
No, sir.
No?
No, sir.
Okay. Okay, I have a couple of minutes, so let's quickly do that. So go to onlinetonegenerator.com. So what you will see is, you will see a box here where you can change the hertz. Okay, you can change the volume here. So I'm going to remove my head sound directly. Can you hear me? Yes, no?
Yes, sir.
Yes, sir. We can hear you.
Yes, sir.
Yes.
Okay, so you can try this yourself, but I know I want you to try it in a proper method. So put some 440 hertz, then play it. Let me switch off the fan here, ceiling fan, so that you can hear it better. Can you hear the frequency? Nobody's hearing?
No, sir.
Brother,
No?
not able to hear. No
Not
voice.
clear? Okay, let's try increasing this. Can you hear it? No?
No, sir.
No? Okay. Okay, doesn't matter. So I'll try to record this and I'll send it to you. You can take a look at it. So what's happening here is, the very important aspect of this table is you have to understand the differences, okay? Because all of them will look very similar, okay? So you have to understand the very subtle differences. Only then this chapter will make sense. Otherwise, it's going to be a very difficult chapter. In my opinion, if you know trigonometry, this is a very, very simple chapter. So look at this, y1, y2. So if you have two waves with slightly different frequencies, you see waves of slightly different frequencies. What will happen is, I want you to try this experiment in your home. So open this and go to one more tab and open one more online tone generator. Okay. So play this, you will see one frequency running. And then in the next one, I want you to play around with this frequency. So instead of 540, play it as 541. And then keep the volume same and play it. And play it. If you stop it, right, you will hear only one frequency. But when you play both the things, what you will see is, you will see like, rising and falling waves. Did you hear that? Did you hear, like, going up and going down, going up and going down, something like that? Didn't hear anything like that. I kept the volume maximum, so I don't know what else you can do.
Can you play again?
Okay.
Oh, yes, sir, we can hear it.
Yeah, this was heard. This was like a tuning for coils.
Yeah, something like a tuning fork. But what I want you to observe is it's like, rising and falling. Rising, falling, rising, falling. I don't know why I kept the volume maximum, but still you're saying you folks are not able to hear. Maybe I try to increase the frequency a little more, 600. I think this is better. Can you hear it?
Yes, sir.
So you can see it's going up and down. If I stop one of them, that's a continuous frequency, 600 hertz. But if I play it, so you should be able to hear that, rising and falling of the sound waves. Okay, and that is what we call it as beats. Okay. So sine omega t, omega 1, omega 2, what does that mean? Slightly different frequencies. Again, use the same formula, y1 plus y2, sine c plus sine d, sine c plus d by 2, sine c minus d by 2, you will get this. And the frequency of the beats, what I was showing you, right? If you keep the frequency difference as 1, if you keep 600 here and 601 here, you will see for every 1 second there is a rise and fall. But suppose if I make it as 602, then you will see that the rise and fall is very quick, 2 seconds. Suppose if I increase it to 3, suppose if I increase it to 4, suppose if I come back to 1, okay. So what I'm trying to say here is, as the frequency difference changes, so you should play one at say 600 hertz, the other tab you have to play it at 601 hertz, then try to play it at 602 hertz, then try to play it at 603 hertz. So as you keep increasing this, the frequency of the beats is given by nu1 minus nu2. So for example, if this is nu1 and this is nu2, then this will be 1 hertz. This will be 602 minus 600, so it will be 2 hertz. This will be 3 hertz. So what it means is the rise and fall, which you see in 1 second. You remember hertz is 1 second. So it means here you will be seeing the rise and fall in every 1 second. Here you will be seeing rise and fall 2 times for every 1 second. Okay, so that is what we mean by beats. So very, very important topic. You can expect some questions based on this. Okay, so try this, you will get a better idea. So this one, I'll explain it in the next class. Okay, but for now, I think you should get an idea. Okay, so one last topic which is remaining is this one, standing waves. Okay, so most probably I'll be completing this in the next class. So today is Friday, so Monday I will complete. Anybody's exam starting this next week?
Mine,
Sir,
mine's
sir,
on
my school.
even my school, sir.
So okay, so let's see. So many of you are saying the exams are starting next week. Okay. Kirtan, you said who else was that? Uzma.
Uzma.
Okay.
Mine is
okay.
March 2nd.
March. Okay. Who else was that?
Feb 24th.
Feb 24th. Okay. So ISC folks, Roshni, Siddharth, Veer. So I think for you, I think only this part is there, right? Do you have the standing waves also? I don't think you have this. Only up to this, I think you have. Is that correct or not?
Yes,
Yes.
sir. We have very
Yes,
less
sir.
in oscillations.
In waves? And no, I'm talking about waves.
Yes, sir. Under oscillations, we have all the waves and everything, sir.
Okay. Is there any topic which I have not covered for you? I hope I covered more than what is required. Is that right?
So,
Okay. So ISC folks, Hafiza, Roshni, and Veer and Siddharth, if you have any doubts, you can bring it over here. Okay, we can discuss that, or you can we can plan for a separate class if you want any specific doubts. Okay, so 4 of you get together, and we can plan something. Is that okay?
Yes, sir.
Yes,
So
sir.
Yes, sir.
Yes, sir.
other classes you said Feb 24 is your exam, right? So next week, not next week, after that week. Okay. So kinetic theory, do you have it or not? No answers.
Kinetic theory is given, sir.
It's there or it's not there?
1 second, I'll just give it a check.
No, I'm talking about these ISC folks. Kirtan.
ISC, okay.
Yeah.
Sorry.
Okay, no answers. Okay, I'll leave it to you. If you have any issues, you let me know. Others, kinetic theory, anybody who has kinetic theory? That is also
don't know, sir, because sir hasn't started it yet.
not started it. Okay, what about others? Kirtan, Chaitanya, Padmaja, Mithun,
We have it for the exam, sir.
you have it for the exams. Okay.
Sir, we don't have kinetic theory, sir.
You don't have Siddharth and ISC folks. Okay. Okay. Let's see. Any topic which you want help immediately? So next class, I'm planning to do this one. Okay, all these things I have some demonstration. Unfortunately, nobody is able to come here. Okay, even if I ask you to come, I think it's only Ashwant coming.
So I have school until 5. I reach home at 6:30.
Okay. So next year also you're having this, going to have the same trouble. Okay. So in 12th, let me tell you in advance, 12th standard is going to be much more difficult. Okay. Of course, 11th is more difficult. Okay. But then 11th, it's more like a school exam. So whatever is taught in your school, you have to study it properly and then get the marks. But 12th is not like that. Okay. Particularly this year, they had a lot of trouble term 1, term 2. Okay. So we do not know what's going to happen next year. So my suggestion is you have to come to the center. Okay. If you are coming online, no, I don't know how good you are studying. People like Mithun, I do not know. Okay. If you want, we can project it. Okay. As far as possible, out of station students, for them only I will be projecting the class. Okay. For others, I recommend you to come here. Okay. Kirtan. So Sai Baba Khan is just 2 kilometers away from here. Okay. You can plan to come over here. Okay. Again, it's good for you. Okay. It's very, very boring to keep on looking at the computer screen. So that's why I'm saying all these things. So we'll finish this one in the next class, and then I'll get started with kinetic theory. Okay. Again, I do not want to rush through very quickly. Okay. I hope I'm going in the right speed. So if you have any exams started, okay, even if it is something like, English exam or something, you can try to attend it. Okay. If you, in the next day, if you have English or something, try to attend these classes. I think it's not very difficult for you. So if you're not able to attend because of your school exams, so please put me a note in the WhatsApp. Is that okay, everyone?
Yes, sir. Yes, sir.
Others,
Yes.
I expect you to attend. Okay, particularly people who said you have kinetic theory. I will be finishing the standing waves, and then I'll be, taking the kinetic theory concepts. Okay, thank you all. If you have any doubts or anything to be discussed regarding the exams and attending the classes, you can stay back. Otherwise, you are free to go. Thanks. Bye.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.